Welcome to the PrairieLand Advantage. Today we're going to talk about the 9000 series conventional combines, and we're going to talk about crop flow and the adjustments we need to make to assure good crop throw in the threshing section of these conventional combines. To help you find things in the video, we've given you an index here to the sections we're going to talk about as we go through this portion of the combine. Thank you for joining us today. This is Drew Lowry.
And I'm Dave Thiessen, and we will be walking you through the threshing section of the 9000 series combine. First off, we want to start out with a video kind of walking us through how the cylinder and the rasp bar and the concaves work together with the discharge beater to do our threshing part of the section. As you can see in this slide, we have how the crop flows from the feeder house into the threshing section between the rasp bar cylinder and the concaves up through and then on the discharge beater, with the discharge beater having a grate below it, kind of simulating what the concave does. This is just a way that we can better envision how the crop flows through the combine, with the straw walkers taking away the crop material off the back of the discharge beater and the grain coming back down through the shaker pan, landing on the chaffer, which are all other sections that we have on video with straw walkers and the cleaning shoe. This video shows how the threshing action happens in the rasp bar to concave relationship. After the video, we will talk about and walk through some adjustments and things to help you make your machine perform the best it can in small grains.
When wheat is threshed at the proper cylinder speed and concave opening, the crop is separated completely and gently in the front area of the concave, leaving no unthreshed heads. On maximizer combines equipped with the small grain concave, threshed grain falls rapidly through the large openings. If the concave opening is set too wide in small grain, a blanket of material forms between the concave and the cylinder. It's too thick to allow good separation. The heads are not threshed completely, and smaller quantities of grain are separated through the concave. More grain moves to the straw walkers than they were designed to handle, and grain losses will occur. When this happens, start closing the concave. When the concave spacing is too tight, the straw is broken apart and excessive amounts fall through the concave and into the cleaning system. When you find broken straw on the chaffer and straw particles in the grain tank, check the concave spacing. Remember that the cylinder and concave of a maximizer combine work as a team. Adjust only one setting at a time and base it on your harvesting results. Then fine-tune your adjustments as crop conditions change. It can make the difference in grain quality and field performance. After the concave and cylinder, the crop moves to the large diameter beater. Its job is to direct material from the cylinder to the straw walkers. Normally, the beater speed is the same as the cylinder speed. As the cylinder speed is lowered, the beater speed is also lowered. This helps reduce grain damage. When harvesting specialty crops, an option is available to let the beater run 25% slower than the cylinder. A grate below the beater acts like an extension of the concave. Its position is adjustable. Set the grate in the up position when harvesting small grain, and in the down position for less aggressive handling when harvesting corn.
That video helps us to understand better how the rasp bar cylinder and the concaves work together to complete your threshing before it throws it up on the straw walkers. Before we talk too much about concave adjustments and how to set the concaves for your crop conditions, let's take a look at the rasp bar cylinder bars and make sure that we understand when we should be replacing our rasp bar cylinder bars. As you can see in this illustration, if a number 2 yellow pencil was to be set down in between the rasp bars and the top of the number 2 pencil was flush with the top of the rasp bars, that's a good indicator that we should be replacing our rasp bars due to the wear that is lost on top of the rasp bar. Also, I like to look across and see how even they are all the way across. Another example of how to check it, if you have a quarter on you, put the quarter into it touches the bottom of the rasp bar, but if George Washington's nose is starting to appear, that means our rasp bar rasps are starting to be worn to the point where we're going to lose effectiveness on our threshing and separating abilities.
So Dave, should we be checking this in the middle like your picture, like your pencil is shown there?
Well, typically in the middle of the cylinder rasp bars, this area is where the tailings elevator has a tendency to deliver the most material back to. And that's an area that will then show more wear because it has more material being threshed and tried to rethresh it there. And we'll be talking about how to adjust and how to overcome the tailings elevator volume and what that can do to the machine's capacity in our cleaning shoe video that we encourage you to look for on our PrairieLand Advantage. Cylinder bar corn filler plates. That's something that is installed for corn. If you want to maximize the ability of this machine to harvest corn off the ear, these filler plates get installed between the cylinder bars and the rasp cylinder type bars. As you can see, they would latch in underneath the one previous bar ahead of it and then bolt in with some bolts that are in the webs that hold the cylinder bars in place. And when I go into a small grain situation, the best thing we could do is remove those, because when we are in small grains, there's a whipping action of the grain between the cylinder bars that helps start to separate that crop and get that crop to fall through the concaves. And with these filler plates in, that makes it more of a smooth radius, and it doesn't have that whipping action as you've seen in that video to help that material get separated. But when I was to put them back in for corn, if I had very many corn acres to harvest and I wanted to do a good job of getting the kernels off the ear with a minimal amount of adjustments on settings of concave setting or RPMs, I would put these filler plates back in. One secret that we have that you can help yourself is when these filler plates are back in, they have a tendency to want to trap quite a bit of dust and debris inside. And that's what these perforations are for, is to hopefully help that material fall back out when you are harvesting. But one trick is to leave a golf ball and put a golf ball between each one of the cylinder webs. So each one of these section between the bolt holes here, we would drop a golf ball in. That way, when we're starting and stopping that cylinder, those golf balls are keeping that dirt from getting packed, and it helps break it up. So it hopefully falls through those filler plates when we're harvesting and starting and stopping the cylinder. Let's talk just a little bit about concave to rasp bar cylinder adjustments and settings. But let's first off talk about the settings for the concave clearance are only as good as the calibration and the accuracy of what we do. With that said, we want to make sure our concave is level left to right across the width of the feeder house opening underneath there by the threshing door, and also at the rear through inspection doors. And we'll talk about that in upcoming slides. But we also want to make sure our front to rear adjustment of this is also set accurately, and that we have our mechanical stops in place once we get our final adjustments done, and we've reset 0 on our calibration of our concave indicator. Here's an example, as seen in the video, of a rasp bar cylinder to concave relationship with the discharge beater and the discharge beater grate. And let's just talk about this just a little bit. When they come from the factory, the concave to rasp bar cylinder setup adjustments were all set for corn. And that was the best performance this machine could have, was in corn, when we kept an equal spacing in the front and the rear of the concaves. But in particular small grains, we found that we have a lot more straw walker losses, and we have found a way to overcome that. And that's by what we call the wedge effect. The wedge effect takes this pinch point that they talked about on the front of the concave in that video, and it moves it to the rear. So that way we have this full area of crop area where the rasp bar and the concave interact to thresh your crop. We have this wedge effect, the full distance here, that allows, as material falls through the concave, allows the cylinder and the rasp bar and the concave to continue threshing your crop aggressively without just releasing it. In the settings from the factory or the tech manuals talk about, that threshing area would be right here, and then behind this green arrow up towards the back would be released, and it would not have as much threshing action going on. So we've learned over the years that we go ahead and set the front of the concave and the rear of the concave at a different setting. Also in this picture, and we'll talk about it more down in another slide or two, is the discharge beater has 2 holes for selections, and we wanted it, like they talked about in the video for small grains, we wanted in the lower hole or the grain discharge beater in the up position. And also remind me, and we'll talk about the beater grate curtains as we get farther down the slides. Setting the concave to rasp bar cylinder stop and the spacing correctly is critical in how we set up this machine to thresh wheat and keep the losses off the straw walker and as much grain for the straw walkers to manage and handle. So with that said, This would be the upper right-hand concave inspection hole off the side of the machine. This would be the cylinder drive belt, just as a relationship to it. There would be another concave inspection hole up here in the right-hand corner, just in front or below our dual range cylinder drive, if we were envisioning that inspection hole down here. This is what they call the 13th bar of the concave. There is this notch that you see in the concave that should be in front of that inspection hole. And just below that, at the 12th bar down here, is the high bar of the concave. So as we're setting this up for small grains and adjusting it, we want to roll the machine over by hand by disengaging the dual range cylinder drive and pull the lockout pins out. And we want to take and roll this concave up and hand turn the cylinder drive until we hear it start to tick. And when it starts to tick against the rasp bar, we need to follow that rasp bar around with a can of yellow paint. We need to paint the end of the cylinder bar on this end and then go to the left-hand side of the machine and paint the cylinder bar so we know exactly where that cylinder bar is at and which one it is that's the high one. Then with that adjustment made, we want to go ahead and start opening up the front by incremental adjustment and closing the rear down until we come to the point where we don't have that high bar in the middle down here hitting, and we start to get within and start ticking against the concave on the rear with the rasp bars. When that is in that position, we'll have the front open, I'm going to say estimated between 3/8 to a 1/2 inch down here on this hole for the front inspection door. And at the back, we'll just start to tick right here. Once we start to tick and we know we've got it leveled left to right side, then we want to come back in and we want to take the rear concave adjuster and make a gap between the concave and the cylinder bar to about an 1/8 inch, because that cylinder at full RPM of 1000 RPM will grow, and those rasp bars then would hit if we left it in this position right now. With that adjustment, we take and do as much aggressively threshing as we can between the rasp bar and the concaves with our wedge effect, and we prevent from throwing too much loose grain up on top of the straw walkers and overloading our straw walkers. Plus, whatever we don't get threshed out with the rasp bar and concaves gets thrown onto the discharge beater, and the discharge beater grates throws onto the straw walkers, and we are not wanting it to do any more threshing beyond the discharge beater. The separation happens on the straw walkers, and no threshing should happen on the straw walkers. So how do I tell when my concaves maybe need to be replaced? Well, we need to take and look at the distance of material we have above the concave rods or the wires to the relationship of the material that we see here between the hole of the wires and the top of the bar. If I was to go to either the left-hand side or the right-hand side of my concaves and look where there isn't much material flow against the separator sidewalls, I would be able to tell how much original material was on top of my wires. That's where the material hasn't done much threshing and we don't have much wear. Then I would come across to here and I would want to look and see how much material I've lost at the middle of the machine or around where the tailings elevator dumps is one of our areas that wears the most. It should not be more than an 1/8 inch total combined between the rasp type cylinder bar and the concaves. Well, you say an 1/8 inch, but that means only the concave can only have 1/16 of an inch and the rasp bar cylinder should only have 1/16 of an inch. If we're more than that 1/8 inch, we will start to lose performance and effectiveness of how our rasp bar and concave will thresh before we even have those adjustments that we need to start to make. The other thing I want to look at while I'm looking at my concaves is, and this is something that happens and occurs during the harvest, is we need to make sure we don't plug our concaves or have plugged concaves. With that, there's potential that you maybe ingested dirt from a gopher mound or a pile of dirt in the field, or maybe went over a terrace with a header and you ingested some dirt. At that point, or daily in my checkup, when I'm opening up that rock trap, I want to look to see if my concaves might have some dirt debris plugged in them. Or I've seen situations where the customer maybe started up too soon after a shower came through at wheat harvest or soybean harvest, and the material wasn't dry enough to flow, and it plugged the concaves. This next video is going to talk about threshing in the concaves and the inserts at the rear of the concave. And let's play it, and then we'll talk about some more things with concave inserts.
If your Maximizer combine is equipped with a small grain concave, the 5 rear bars have no wires running through them. Being open provides extra separation in small grains. The larger open area also helps minimize grain damage. This concave is recommended for harvesting small grain, low moisture field corn, and any specialty crop. Depending upon variety and crop conditions, the small grain concave may allow too many unthreshed kernels to pass through. This is easily remedied by installing corn inserts to the rear open section of the small grain concave. The inserts hold the crop for complete threshing.
Those rear corn concave inserts, as you can see, blank off the material and keep it inside the concave, getting ready to be handed off to this discharge beater. These inserts are handy if we're breaking cobs up in corn and we need to maintain the cob quality so we don't get little fine chips in the grain tank, or if we have unthreshed wheat heads like they talked about in the video and they want to push through here. Shellborne stripper header owners, this would be inserts that you need in the full set for your Shellborne stripper headers to prevent that material of the head being pushed through before it was fully threshed. And these can be bought and found at your parts department. If we have a situation where we're in small grains and we're having a hard time getting the white caps or the grain to thresh properly, there are front concave closure strips that can be put in from underneath the shoe auger bed front door. You open it up and you latch these to the bottom of the concave. This is actually looking from the bottom of the concave up with these cover closure plates in. Sometimes we have loose grain that's threshed at the header, auger, feeder house chain, and then when it's delivered to the concave, it wants to fall directly through to the shoe augers. And with these cover plates installed, it will hold the material up there and allow the cylinder and the rasp bar in the concave to do its threshing action to hopefully remove those white caps in hard threshing wheat. Let's talk just a little bit like they did in that first video about beater grate position and how important it is in small grains that we have the beater grate in the up position. As you can see here in this illustration, we have an A in the lower hole, so it's in the up position. If we were going into corn and we had a lot of corn to harvest and we had some corn damage that we wanted to prevent, we could drop it into what they call the lowered position on the B slot. One thing to keep in mind as we talk about this though, with small grains in the A position, which is a raised beater grate position, we do have what we call the beater grate curtain that can hang off the back of the discharge beater grate. But if we lowered it into the B position, we have to remove that discharge beater grate curtain to keep from damaging it while the straw walkers are operating underneath here. Let's take a look at that beater grate curtain and that position and how that matters. This is the beater grate curtain that we're talking about. As you can see in this illustration, the straw walkers work just in front of or just behind and just under that curtain. And if we put the beater grate in the lower position, then we hang those curtains down into the straw walkers. If we leave it in the up position, as we would encourage you to do for small grains, then these curtains work the best and they won't get into the straw walkers and they'll be there for many hours of operation. Why do we want beater grate curtains in the first place? Well, as we run this cylinder and the threshing starts to happen at the higher RPMs, typically around that 900 to 1000 RPM, that crop is flying out of there and it's coming out of there at such a momentum that it wants to throw too much loose grain on top of the front part of the walkers. And when that happens, then we have material that has to be worked back off the front of the walkers down onto the shoe augers. With this beater grate curtain in here, we stop that flow through of that material and that momentum and keep it from getting on the walkers too far. Keep in mind, like we talked about, you have to keep your discharge beater grate in the upper position or else these beater grate curtains will hang on top of the walkers and be torn up by the walkers. Here's an example of what it looks like on those shoe augers from underneath the concaves and how they are there to pull the grain away from the back and the bottom of the concave and pull it towards the pre-cleaner as we start that cleaning shoe transition. One thing we've seen over the years is if you start up a harvest and maybe the crop isn't completely dried out, or you've started into a harvest just after a shower and the shoe auger beds had water in them or moisture in them, or the crop wasn't quite dry, it starts to bridge up on top of those shoe augers and the shoe augers will tunnel underneath there. And then the crop transition won't fall down on the shoe augers and it blocks or blanks off the front of the concave and plugs the concave. That just takes away the threshing and separating area of the concaves that we need to utilize for the machine's capacity. So every once in a while, I would encourage you to stop and check underneath your machine, especially daily when you're dumping your rock trap. Just take a look up in there and see if you've got any material blocking your concaves and you're losing some of your threshing ability. As we take a look at the threshing section of our machine, we also want to talk about the cylinder drives and how important it is for those cylinder drives to be maintained in a way that will give you good performance through your harvest season. Let's first start talking about the dual range cylinder drive. The dual range cylinder drive in the operator's manual talks about an arrow that you put at the 12 o'clock position, and you pull this plug and you check your oil level. Well, with the arrow at the 12 o'clock position, that puts that plug down here about the 7 o'clock position for oil level. And what we've found is that's just slightly more oil than it should have in that gear case, because it'll want to push maybe some oil out the seals and cause you a frustration of getting some 80-90 weight oil on the belts. My advice, or our advice at PrairieLand Partners, would be to remove that plug and roll that arrow to the 11 o'clock position, which puts the plug about the 6:30, 6:45 position down here, just a little bit lower than the 12 o'clock position on that arrow up here. And it allows us to maintain the oil level that's the correct level, so we don't have seals that are going to potentially leak on you and cause trouble for your threshing on your drives. The other thing to pay attention to and spend a little bit of time with before you go to the harvest field is run your cylinder drives all the way up into the fast position. So that would mean the upper cylinder drive here, the pulley would be closed, and this lower drive sheave assembly unit would be spread open. Inside the center of that sheave, then there's a can or a cavity for grease that we're going to go ahead and want to fill with grease. With it sped all the way up into the fast position, we want to take and remove a brass plug that is down here 180 degrees between the spokes, 180 degrees apart from where our zerk is in the spokes. With that brass plug out, then I want to pump grease, TY6341, the multi-purpose grease, into that zerk until I start to see grease come out this brass plug. When I know it's coming out this brass plug, I'll put the brass plug in, close it all up. I'll go back up into the cab, make sure no bystanders are around. I'll run it up and down in speed and apply that fresh grease inside those cams, so we make sure that our cams are appropriately greased. This is a posi-torque cylinder drive system, and these cylinder belts will pull the load and do a good job of threshing and keeping that cylinder up to RPM if we keep these cylinder drive cams greased like they should be. The other thing that's important is once we've greased those cams and slowed it all back down, before I went to the harvest field, I would want to make sure that I have a 1/4 inch sheave gap. How do I check that? I would slow down my cylinder drive all the way. I would then look inside between these sheaves and make sure that I have a 1/4 inch sheave gap by using either a 1/4 inch drill or some type of measuring device, so the sheaves are 1/4 inch apart. How do I adjust that? Well, that's what this tie rod and this bolt are down here for. That takes and helps pivot this whole sheave assembly and this whole lower unit sheave group away from the upper cylinder drive, which will pull the belt tighter. Or if I had too much sheave gap, I'd want to release it. When I'm making these adjustments, though, I'd want to make incremental adjustments on this rod. And then when no bystanders are around, I'd go ahead and run the cylinder drives up to full speed and back down to see if that sheave gap is held at that position. That way I know my belt is relaxed and is under the right tension with that posi-torque drive, so I know it's going to pull my cylinder and not potentially plug or tear a belt when I go to harvest. There's the brass plug in between the spokes of what we talked about earlier. That concludes the threshing section of the 9000 series walker, and PrairieLand Partners, this is how we deliver the right solution.